Hi everyone, this is the model answer for the resistance, voltage and current higher exam question. A student is investigating some electrical components. Describe how the student could set up a circuit to find the resistance of a lamp. You should include a circuit diagram in your answer. Okay, so in order to work out resistance, we need to remember the equation V equals I times R. Or potential difference equals current times resistance. So to find resistance, we need to do our potential difference divided by current. We also need a way of measuring the potential difference and the current. So I'm going to draw the setup of the circuit that you will need. So I'm going to pop a battery in. Remember, a battery can be made up of 2 cells. I'm going to also put my lamp in, or bulb, because that's what it's telling me it wants to measure. Using a ruler to draw our circuit diagrams to make sure they are nice and they are neat. And then I'm going to put in a device for measuring one of these quantities. Now, to measure current is an ammeter, and ammeters are connected in series with the device that you are measuring the current through. So series, remember, series circuit is just one loop like this. To measure the potential difference across the lamp, I need to connect a voltmeter. Now, voltmeters are connected in parallel or across the component that you want to measure the potential difference of. So if I want to measure the potential difference of the lamp, I'm going to put it across the lamp. And that gives me a really nice circuit that I can then use to investigate this answer. Okay, and then we need to put a few words down with this. So we're going to measure the current through the lamp using the ammeter. And I'm going to measure the potential difference across the lamp with the voltmeter. Measure the potential difference, or PD, across the lamp using the voltmeter. Okay, and then the last step is to talk about calculate the resistance. By dividing PD, or potential difference, by the current. Let's move that up a bit. Okay, so we recognise what equation we need. We also recognise the setup of the experiment that we need. We need to measure the current with the ammeter, the potential difference with the voltmeter, and then we need to use those values in order to calculate resistance by dividing the potential difference by the current. For the next part of the question, we've got a little bit of a graph to look at. The student is given an electrical component in a sealed box. She has to find out what the electrical component is by experiment. The student records the current and potential difference for the component. Her results are shown in the figure below. Okay, so here we've got current and we've got potential difference. This is a very interesting graph. It's a very characteristic graph, and it's showing us that for this side, we don't have a current, or we have a very low current for these potential differences, for the negative potential differences. Explain how the student could know that the electrical component in the sealed box is not an ohmic conductor. Right, so when you learn about ohmic conductors, if you were to draw their graph, it would be a nice straight line. Now, in maths, a nice straight line like that through the origin is called directly proportional. Okay, so for 1 mark, we're going to say for ohmic conductors, the current is directly proportional to the potential difference. That will be 1 mark. Okay, so for the second mark, we need to say why this doesn't show it. And it's because the graph is curved. If it was an ohmic conductor, we'd expect a straight line graph through the origin. So we're going to put this graph is curved, so it's not an ohmic conductor. So it is not an ohmic conductor. It's actually a non-ohmic conductor. Very inventive words. What is the electrical component in the sealed box? So you should have been looking at your component graphs, and this one is a really easy one to identify, and it's that of a diode. Okay, and it's because it only really allows current one way because it's got a super high resistance in the opposite direction. So the component is a diode. For our explanation, it's because it has a high resistance with negative potential differences. With negative potential differences. And it also has a low resistance for positive potential differences. And has a low resistance for positive potential differences. So a diode, it works by only letting current go in one direction. Okay. And then on to the last question. Use the graph to determine the resistance of the component at 2.3 volts. Okay, so if we go back to our graph and we're looking for 2.3 volts, so 2.1, 2, 3. So it's here. Now because it's a curve, we need to draw a tangent to it. So a tangent is a line that just kisses the curve on that point. You need to do this with a sharp pencil, unlike me who's trying to do it with a pen. Okay? And then what you need to do is work out the gradient of that line. So gradients, remember from maths, is change in y divided by change in x, or you might remember it as rise over run. Now to do this, I'm going to make myself a nice little triangle that goes through what I call nice points. Nice points go in between the squares quite nicely. Okay, and use a ruler. I am going to go from the top of my triangle across to the y-axis from the top, and then going to do the same from the bottom. Okay, then I need to know what these values are. So that is 0.1234 and this is 2.123. So to work out the change in y, I'm going to do 2.3 minus 0.4, and that will tell me what my rise is. So 2.3 minus 0.4, it's going to be 1.9. So change in y is 1.9. And then need to do the same for my change in x. Okay. So here I've gone from 1.5, 6, 7, 8, 9. So that's 1.9. And that's 2.5, 6, 7, 8, 9, 2.9. So that's actually going to be 2.9, take away 1.9. That'll give me 1. Go back to my working out page now. So I'll do gradient of tangent equals change in y divided by change in x. My change in y, I've worked out, is 1.9. And my change in x is 1, which actually gives me a value of 1.9. Okay, another thing to actually notice when we're doing this is to look back at the equation that we used earlier. So for resistance, it's potential difference divided by current. For my gradient, it's actually the opposite way around. So my y is the current and my potential difference is the x. So it's actually the other way around. And this is why you've got to be really clever and then use those tricky little maths tricks. To get r, you need to swap them over. And one way of doing that is to do 1 divided by the gradient. If you did the working out up to here, you would get 3 marks. So the last marks is for realising that you need to do 1 divided by 1.9. So 1 divided by 1.9 gives me 0.53. Okay, so that is a little bit trickier, and it's based around you realising this and what the gradient means. So you really need to be looking at what it says on your y and x axes. Now, people might do their tangents in a slightly different angle. So there's actually a range of values you can have for this. And the range goes from 0.5 to 0.65. So really well done if you've managed to do that and you've got within that range, because it's quite a tricky question. And if you're not sure on how to do tangents, or if you need any more help, then if you please email me and I'll get back to you with some answers. Thank you very much for completing this question.